Have you ever wondered what happens when a country rebuilds itself from the ground up? Welcome to China's infrastructure revolution, a quiet storm of steel, concrete, and pure ambition. Right now, tunnels longer than entire cities are being drilled. Ports that load ships without a single human hand are rising from the sea, and rivers are being redirected like garden hoses. Stick around because what you are about to see will blow your mind. But first, hit that subscribe button and click the notification bell so you never miss another breakthrough in cutting-edge technology. Let's dive in. Construction crews are moving rapidly on a massive 10 billion yuan automated terminal at Shanghai Yangshan Port, marking another major step in China's drive to expand its global shipping power. The project is centered on the Xiamen-Kinmen North Operation Area, a newly developed section designed to handle the rising demand for international trade and cargo transport. Once completed, the new terminal is expected to process an impressive 11.6 million TEUs annually, placing it among the world's most advanced and busiest automated port facilities. Engineers and workers continue building large-scale infrastructure along the coastline, while automated systems are being prepared to improve loading speed, cargo handling, and shipping efficiency. The expansion will also add around 6,100 meters of coastline to the operational area of Yangshan Port, greatly increasing its capacity for future trade activity. The project reflects China's larger strategy of combining smart automation with modern maritime infrastructure to strengthen supply chains and global logistics networks. The Yellow River has always been trouble. It floods, it shifts, it keeps engineers awake at night. But now, a new project called the Gushan Water Conservancy Hub is fighting back. Builders just finished 2 giant diversion tunnels. Think of them as emergency exits for the river itself. These tunnels redirect water while construction happens upstream. That makes the whole process safer and much faster. Experts call Gushan a new backbone of water control on the river's mainstream. Work started in 2024. Full completion is expected around 2033. That is a long wait, but the payoff is huge. Water resource management along the Yellow River has always been a nightmare. This dam changes the game. It will store water during wet years and release it during dry ones. A bridge is just steel and concrete, but sometimes it is also a message. The Xiamen-Kinmen Bridge project just took a huge step forward. Workers successfully set the first steel box girder for the Xiamen section on December 22. That might sound technical, but it is actually a very big deal. A steel box girder is like the spine of a bridge. It holds everything together. Placing the first one means the bridge is officially on its way. This is not a normal bridge. It will cross the sea and physically connect 2 sides of a very famous strait. Cross-sea connectivity has been a dream for decades. Now it is becoming real. The bridge will shorten travel time between Xiamen and Kinmen dramatically. Digging a 134-kilometer canal through tough land is insane. But that is exactly what China is doing with the Pinglu Canal in Guangxi. Workers just finished installing metal structures for all 3 major shipping hubs along the route. That means the main construction is basically done. The canal has 3 cascade hubs with cool names: Madao, Kishi, and Youth. At the Madao hub, the team connected the last set of ship lock gates to the hydraulic hoist. That is engineering poetry. The numbers are stunning. 95.5% of the investment is already spent. About 93% of the waterway project is complete. Over 95% of the whole thing is finished. The Nanning section is already running ships. Next steps are boring but important. Finishing leftover excavation and building support systems. Inland waterway transport is about to get a massive upgrade. The Pinglu Canal is a flagship project of the new Western Land Sea Corridor. That corridor is China's bold plan to move goods from the western interior straight to the ocean without going through crowded eastern ports. Freight logistics will become much more flexible. Ships will bypass bottlenecks, and regional trade will flow like never before. This canal is not just a ditch, it is a shortcut to prosperity. Driving through the Tian Shan Mountains used to take hours. Now it takes 20 minutes. That is the magic of the Tiansheng-Shengli Tunnel. It stretches 22.13 kilometers, making it the world's longest expressway tunnel. Builders opened it on a Friday, and the celebration was well-deserved. The tunnel faces insane geological pressure. A piece of rock the size of your finger inside that mountain has to bear over 200 kilograms of weight. That is like balancing a grown man on your thumbnail. To handle that, builders used China's own rock drilling machines. They split the tunnel into sections to make the job easier. That clever trick cut construction time by 25%. The tunnel is part of the G711 Urumqi-Yuli Expressway, a 324.7-kilometer beast, built with 46.7 billion yuan. That highway cuts travel between Urumqi and Korla from 7 hours down to just 3. One section alone has 14 bridges and 5 tunnels. The bridge-tunnel ratio there is over 90%. That means engineers were basically building roads on top of roads. Most tunnels are dug from the outside in, but not this one. In Shenzhen's Yuanshan Underground Mountain, a massive tunnel boring machine started chewing through rock from deep inside. That has never been done before in China at this scale. The machine's diameter is 14.31 meters. That is wider than most city streets. It is working on the Henggang section of the Longgang Tunnel for the Shenzhen-Shantou Railway. This marks the first time an ultra-large diameter TBM has completed the entire tunneling process underground. Why does that matter? Because starting from inside a mountain is much harder than starting from an open pit. The machine has to be assembled in darkness. It has to be aimed perfectly without visual references. And it has to remove rock without any easy access for trucks. Let's break down what makes this so extraordinary. Typically, engineers excavate a launch pit at the tunnel's entrance, lower the TBM in pieces, and assemble it under an open sky. That gives them room for cranes, trucks, and survey equipment. But inside a mountain, none of that exists. The TBM parts had to be transported through narrow, pre-dug access tunnels, then bolted together in a cramped, pitch-black cavern with only artificial light. Every segment had to fit precisely, no room for error. And because there's no direct path to the surface, the machine must simultaneously grind through rock while managing its own debris removal system, sending crushed stone back along the same tight corridors. It's like building a ship inside a bottle, then sailing it out. Tunnel boring machines have become incredibly smart. They use lasers, sensors, and computers to stay on course. In this case, the guidance system had to establish its position relative to the mountain's interior without any line of sight to the outside world. Surveyors used a network of gyroscopes and precision targets to orient the TBM's starting direction to within millimeters. Once boring began, the machine's cutter head, studded with tungsten carbide discs, spun against granite and basalt, exerting over 20,000 kilonewtons of thrust. Meanwhile, hydraulic jacks pushed the following segments of precast concrete lining into place, sealing the tunnel behind it. This one is paving the way for high-speed rail that runs right through a major city without disrupting life above ground. Instead of blasting surface tracks through dense neighborhoods or relocating thousands of residents, engineers can now thread a railway silently beneath existing buildings, roads, and parks. The Shenzhen-Shantou Railway will eventually carry trains at 350 kilometers per hour, slashing travel times between two economic powerhouses. Urban rail construction is entering a new era. Trains will soon zip beneath Shenzhen like silent fish, and nobody on the surface will even know they are there. High altitude makes everything harder. The air is thin, The cold is brutal, the construction season is short, but none of that stopped the team building the Pasi hydropower project in Tibet. They just capped the main dam, making it the world's highest asphalt concrete core gravel dam over 100 meters tall. The dam stands 108 meters high. That is roughly the height of a 5-story building. It holds back a reservoir of 375 million cubic meters of water. The power station inside generates 58 megawatts of electricity, and the irrigation system covers 42,800 mu of farmland. Total investment was 2.937 billion yuan. The builders overcame oxygen deficiency, freezing weather, and a painfully short working season. They invented new high-altitude construction techniques on the fly, and they finished 5 months ahead of schedule after 3 brutal years of work. High-altitude construction is a niche skill, but this team mastered it. Renewable energy infrastructure in remote areas like Tibet is critical. A high-speed railway is born when the first rail touches the ground. That moment just happened for the Jinan-Binzhou high-speed railway in Shandong province. Workers smoothly laid the first pair of 500-meter-long steel rails on the ballastless trackbed of the Huibin No. 2 Grand Bridge. That is a landmark milestone. It means the project is now in its track-laying phase. Think of it as the final sprint before the finish line. This railway is not a small side project. It is a key piece of the Tianjin-Weifang high-speed railway and the Lubei corridor. It also connects the Beijing, Shanghai, and Qingdao-Taiyuan corridors within the national 8 vertical and 8 horizontal high-speed rail network. That is a lot of jargon, but here is the simple truth. This line will connect places that currently have no high-speed rail. Jiang District, Shanghai County, and the main urban area of Binzhou will finally join the network. High-speed rail expansion is changing who gets to ride fast trains. Regional transportation networks become more useful when every small city is connected. Once this line opens, traveling across northern Shandong will feel completely different. Business trips will take hours instead of days. Family visits will become weekend adventures instead of exhausting journeys. The economic boost will be real and immediate. Hainan is becoming a free trade port. That means more business, more people, and much more demand for electricity. So where does all that power come from? The answer lies deep beneath the ocean. The Deep Sea No. 1 Phase 2 cluster is the energy heart of the island. This is not a solar farm or a wind turbine. It is an underwater natural gas field that feeds power plants on land. Offshore energy production is tricky, dangerous, and expensive, but it is also incredibly reliable. Unlike solar or wind, deep-sea gas flows 24 hours a day, rain or shine. As Hainan opens up to global trade, its energy needs will skyrocket. Data centers, cold storage warehouses, hotels, and factories all need massive amounts of electricity. The Deep Sea No. 1 cluster is ready to provide it. Energy security is the quiet foundation of every economic miracle. Without power, nothing works. The lights stay on in Hainan because of brave engineering happening miles offshore and thousands of feet underwater. Next time you visit the island and enjoy a cold drink or a bright hotel room, remember the gas flowing up from the dark sea floor. That is the real magic, keeping the party going. Bridges are supposed to stand straight. This one does not. The Jiangjunzhou Bridge in Nanchang just topped out its main tower, setting a new record for the world's tallest composite structure inclined pylon. That means the tower leans on purpose, and nobody has ever built one this tall. The bridge spans 1,827 meters in total length, with a main span of 225 meters. It uses a cable-stayed steel design with no backstays. That is unusual. Most cable-stayed bridges need backstays for balance. This one does not. The deck is 10 to 14 meters wide and carries 2 lanes of traffic in both directions. When finished, this bridge will hold 2 world records: the largest span cable-stayed bridge without backstays and the tallest composite structure inclined tower. Innovative bridge design like this pushes the limits of physics. Structural engineering becomes an art form. Airports and train stations are usually separate, not at Tianfu Station. This massive hub in Sichuan's Tianfu New area is different. It is the first TOD integrated railway station in the province. That means everything, trains, subways, buses, and even airports, is designed to work together seamlessly. The station has a total construction area of 612,000 square meters. It features 12 platforms and 22 lines. Passengers can hop on Metro Line 18 or 19 and ride straight to Chengdu Tianfu International Airport or Shuangliu International Airport. That is convenience on a ridiculous scale. The station's design is even more impressive. It uses a non-centripetal ellipsoidal steel grid shell structure. That is a mouthful, but the nickname is better: the Phoenix Eye. 2 massive structures sit on both sides of the station building. They are 102 meters long, 34 meters wide, and 33.5 meters high. Each one is made of 1,221 bent and twisted steel components. The design concept is structure replacing decoration.